If I have two different systems for doing the same thing, so I have rectangular coordinates and polar coordinates for naming points, it seems like I should be able to convert back and forth to name the same point in either way, either polar or rectangular form, and indeed we can. So we're going to look at, if I have a point in rectangular form, how to change it into its polar form. And we'll think back, if we have a point x and y, we can find its distance away from the origin. Essentially, we're using the distance formula from 0, 0 to xy. So we have x minus 0 squared plus y minus 0 squared. And there's how we'll find r if I have x and y. Something else that we know is that the tangent of the angle around to x comma y is y over x. Notice I did not say theta equals arctangent of y over x, and there's a reason for that I'll point out in a moment. Let's look at how this works. So there's what we're going to do to find r and theta if we know x and y. So, for example, I have the point negative 4 root 3, comma, negative 4. That's in rectangular form, and I want to change it to polar form. So I'm going to notice this point is in quadrant 3. X is negative, y is negative, so it's I don't know where. It's somewhere over here. And we can name it with x and y, or we can name it with r and theta. Well, here we go with r. R is the square root of x squared plus y squared. I didn't put the negatives on there because whether it's negative or positive, it's going to wind up positive. So I'm just saving some writing there. Let's see, 4 squared is 16, root 3 squared is 3, 16 times 3 is 48. 4 squared is still 16, so I get r is the square root of 64, which is 8. Okay, so I got a value of r. Now we need a theta. And we got tangent theta is y over x. We can simplify that. Let's see, negative divided by negative is positive, 4 divided by 4 is 1, so 1 over root 3. If you like the rationalized version, it's root 3 over 3. Now, if I say arctangent of theta, my calculator will give me the angle that has a tangent value of root 3 over 3 that is in the range of the arctangent function, which is quadrants 1 and 4. It will tell me pi over 6. If r is 8 and theta is pi over 6, I am not in quadrant 3. I'm in quadrant 1, up here somewhere. So I need not the inverse tangent of this, but the angle whose tangent value is root 3 over 3 that's in the right place. That's where my point is in quadrant 3. And that'll be, well, I know the reference angle is pi over 6, so in quadrant 3 that's 7 pi over 6. Not 1 pi over 6. So you can use the arctangent to figure out the reference angle. I know it's something over 6, but we have to adjust so that we're in the right quadrant. So I got a value of r, got a value of theta. That means my point in its polar form, r theta.